Assalamualaikum and hi to Dr. Khairul Nisa. My name is Muhammad Haidil bin Rosmin. I will present to you dispersion. Firstly, introduction. Atmospheric dispersion modeling or ADM is a mathematical simulation of the dispersion of air pollutants in the surrounding environment. Computer programs with algorithms to solve mathematical problems are used to carry out ADM. Next is physical explanation. Here are the key aspects to explain the physical properties of ADM. First is mathematical simulation of air pollutant dispersion, estimating downwind ambient concentration, predicting future concentrations under specific scenarios, regulatory and epidemiological applications. Lastly, importance of meteorological conditions, emission rates and topographical information. There are four types of ADM. First is Gaussian models, Lagrangian models, Eulerian models, and lastly is simulating the dispersion of atmospheric pollutants. Then, this is the general equation of Gaussian model, where C represents steady state concentration, Q is emission rate, sigma represent horizontal and vertical spread parameters, U is average wind speed, Y is horizontal distance from plume, Z is vertical distance from ground level, and H is effective stack height. This is the horizontal dispersion coefficient, and this is vertical dispersion coefficient graph. Next, table 20.1 shows the stability classifications, and table 20.2 is the values of curve fit constants for calculating dispersion coefficients as a function of downwind distance and atmospheric stability. Next is dependence of concentration on averaging time. This is the equation to find the CT, where the CT is actually a concentration for averaging time T, and T is the averaging time itself. Next, this is the graph of Cu over Q max against X max. Next is tall stacks and plume rise. This is the plume rise equation. This is the stability equation, where delta theta over delta z is the potential temperature gradient and S is the stability. Then this is the buoyancy flux equation, where FB represents buoyancy flux, G represents gravitational constant, MWS is molecular weight of the stack gas, and P naught is the standard sea level pressure. Next is critical wind speed. Critical wind speed is the minimum wind speed required for effective dispersion for air pollutants. In general, the higher the stability of the atmosphere, the higher the critical wind speed required for effective dispersion. Conversely, in unstable atmospheric conditions, lower wind speeds may be sufficient for effective dispersion. Next is other stacks design consideration. Recirculating eddies and wake formation occur behind structures, which may result in plume downwash. Turbulence caused by buildings may extend up to twice the building height and downwind 5 to 10 times the height. A common rule of thumb for stack designers is to make the stack height at least 2.5 times the height of the tallest nearby building. Computer programming for dispersion modeling. Atmospheric dispersion modeling is a mathematical simulation of how air pollutants disperse in the ambient atmosphere. The most widely used models today are the Gaussian models, which have various modifications to account for different conditions such as elevated inversions, line or area sources, and topography. These models are important for governmental agencies tasked with protecting and managing ambient air quality. Mobile sources and line sources model. Mobile sources, particularly light-duty vehicles (LDVs), emit large amounts of CO, NOx, and VOCs. Heavy-duty vehicles (HDVs) emit nitrogen oxide at much higher rates than LDVs, despite comprising only 10% of all vehicles. Fleet average emission factors are calculated for a current or future year, taking into account the age distribution of vehicles, engine and control device efficiency, driving cycle, and other variables. Last but not least, conclusion. One of the most important tools for comprehending how air pollutants behave in the environment is atmospheric dispersion modeling. The dispersion of contaminants is estimated and predicted through the utilization of Gaussian-based model. These models are used to evaluate compliance with air quality regulations and are especially significant for regulatory authorities. The chapters also covers the usage of particular computer programs including Mobile 6 and CA Line 3 for this purpose, as well as the significance of fleet average emission factors in modeling vehicle emissions. In the conclusion, it is emphasized how important it is to take into account a variety of parameters when modeling the emissions and dispersion of air pollutants, including vehicle types, driving conditions, and environmental variables. That's all from me. Thank you.